Hey everybody, this is Mr. Wyrick, and I'm here to kind of walk you through these notes. Hopefully we get through it, everything's going good, and we'll be back on track when I come back on Tuesday. Keep in mind the paper from Friday, it's still probably over. I have some extra copies on the shelf where we usually have our papers. We're going to go over that on Tuesday, so if you missed Friday or you have that done and you were looking to see what some of the answers were, we'll go over that Tuesday when I'm back in school. For today, we're talking about similarity and the Pythagorean theorem. We're going to be going over this for a couple days. It's one of the last things that we're covering. We should have a review on Thursday and a test on Friday, I believe, or a review on Wednesday and a test on Thursday. And that will put us doing corrections, whatever, getting the review for the final exam out, and then taking the final exam next week. So it's going to go by really fast. For today, similarity in the Pythagorean theorem, we have some Pythagorean triples. So if you're doing this video, go ahead and pause it and take a look at this and say which sets of numbers are going to work to make a right triangle using the Pythagorean theorem. So does a squared plus b squared equal c squared? Remember that c is always going to be the largest number that we have. And I couldn't get slides to work properly with radical signs, square root signs. So that second one is 1, 1, and then it's supposed to be the square root of 2. The fourth one there is supposed to be 2, 5, and then the square root of 29. And then it's supposed to be 6, 11, and the square root of 17 there on the bottom page. So pause this video. Look where the camera is on the phone. Pause this video and work your way through those and see which ones work. Okay, so not every single one of these is going to work. 5, 7, and 9 very obviously doesn't work. 1, 1, 3 is not going to work. 6, 11 square root of 17 is not going to work. But 1 squared plus 1 squared does equal the square root of 2 squared. 3 squared plus 4 squared does equal 5 squared. And that last one was kind of a surprise to me. 33, 56, and 65, they do equal each other. So what is a Pythagorean triple? Well, on the next slide, Pythagorean triples are numbers that will work with the Pythagorean theorem and its whole numbers. So the most common ones that you see on tests, especially standardized tests, the ACT, the SAT, are 3, 4, 5, and 5, 12, 13. If it's not one of those two, there's an interesting property of Pythagorean triples that you can use, which if you take one of these and you multiply everything by 2 or 3 or 4, you see what happens. Well, 3 squared is 9. 4 squared is 16, 5 squared is 25, and 9 plus 16 makes 25. If we multiply all those numbers by 2, we get 6, 8, and 10. Well, 6 squared is 36, 8 squared is 64, and if you add those together, you get 100, which is 10 squared. If you multiply those by 10, and we have 30, 40, and 50, 30 squared is 900. 40 squared is 1600. And 5 squared, or 50 squared, is 2500, 2500. And if you add the 900 and the 1600, you get 2500. So if you multiply a Pythagorean triple by a positive whole number, you end up with another Pythagorean triple. So if it's not 3, 4, 5 or 5, 12, 13 on that standardized test, it's probably going to be some kind of derivative of those two, multiplying them by 2, multiplying them by 3, multiplying them by 4, something like that. The proof is actually on that next slide. So I've multiplied each individual thing before squaring them by 2. I've then squared all of them and then factored out that 4, and we still end up with the same thing on both sides. A Pythagorean theorem, any triple that's going to work with that, if we multiply it by some number all the way across, we end up with another Pythagorean triple. So that's actually where we're going to stop the notes for today. We're going to talk about how that works with similar triangles and give you some places to try to apply that in tomorrow's lesson after we go over the paper from Friday. So good luck with that. Make sure to behave for the sub, and thanks very much.